Recording now, this is lesson 7.4 on graphing patterns. Before watching the recording, please make sure that you have a graph sheet of paper in front of you, along with a pencil, a ruler, and perhaps a different colored pen if you would like one. So if you need to pause the recording to grab those items, please feel free to do so. I'm going to continue. Please make sure that you record today's date at the top left-hand corner of your page, along with the title, which is 7.4 Graphing Patterns. What we'll be doing today is we'll be building on the previous lessons from this unit. So we will still be dealing with patterns. We'll be dealing with writing the pattern out in a t-table. We'll deal with writing an algebraic expression or summarizing the pattern of values that we see in a t-table. And the next piece we'll add is being able to graph the pattern on an XY coordinate grid. So the first thing we'll do is we'll look at Math Makes Sense, page 30. I'll just jot down the textbook page number here. Now what I've done is I've actually just cropped the first part of the page so that we'll work through the example together. If you notice, they've got two patterns here, but they're actually the same pattern depicted slightly differently. One is on a graph sheet of paper and the other is just with tiles in the image there. So what we're going to do first is we're going to represent this pattern using a t-table. So we're going to actually have three columns for our t-table. The first two columns you'll be familiar with. So actually let's just do two columns first. So take your ruler and then what we'll do, as you should know from previous lessons, you know that the left side of the table is always called the input, and therefore the right side of the t-table is called the output. The right side of values is called the output. Now this time we know that the input is x, and this time we'll call the output values y, okay? This will be significant later on once we plot the values on a graph. So in this case, our input numbers are represented by the figure numbers. So I'm just going to highlight that here. So we have figure 1, we have figure 2, 3, 4, 5. So our table of values will only go from 1 to 5 here. So for x, and I'm going to use pencil here. 1, 2, 3, 4, 5. So remember that anything I copied down in black, you should be doing in pencil on your page. Now, we have to figure out what the output is, or the y values. Now, the y values, in this case, if we look back to the pattern, it's the number of tiles in each figure. So if we look at figure 1 here, we see that figure 1 has 3 tiles. If we look at figure 2 here, we see that it has 5 tiles. If we look at figure 3, as you can count, we know it has 7 tiles, and then figure 4, 9, and then figure 5, we know has 11, okay? So the next piece that we're going to be dealing with, again, you've done in previous lessons, is you have to figure out what the pattern rule is. So let's break that down. Now, what do you have to do to the input to get to the output? Because in this case, if we do that, then perhaps we can predict how many tiles would be, say, in figure 10 without having to extend the t-table. So if you remember the trick from a previous lesson, go ahead and try to find the pattern rule, okay? And then I also am going to ask you, turn that into an algebraic expression. Remember, an algebraic expression has no equal sign. It's a combination of variables, so you can choose any variable that you want to, along with operations such as multiplication, division, and addition, subtraction. Don't forget the golden rule of the pattern rule is that you always have multiplication and division before addition and subtraction. So go ahead and pause the recording and figure out what the pattern rule is, as well as the algebraic expression. Now, I'm going to continue if you do want a review on that. So I'm going to take a different colored pen here. And remember, there is a trick if you find out the difference between the output values. Because in this case, I can already tell that probably the first operation we're going to deal with is multiplication, because the input values are less than the output values. So what number are we going to multiply by? Well, that clue could be in the difference of the output values. So what's the difference between 3 and 5? We know that the difference is 2. What's the difference between 5 and 7? We know that the difference is 2. And then etc., etc. We know that the difference between all the output values is 2. So let's test this and see if 2 is the number that you're going to multiply by the input to get to the output. 1 times 2 is 2. How do you get from 2 to 3? You add 1. Okay. What's 2 times 2? 2 times 2 is 4. How do you get from 4 to 5? You add 1. What's 3 times 2? 3 times 2 is 6. How do you get from 6 to 7? You add 1. And then I'll just do number 4 here. What's 4 times 2? 4 times 2 is 8. How do you get from 8 to 9? You add 1. So you know that the pattern rule has to be multiply by 2, multiply the input number by 2, and add 1. Now here, I'm going to say multiply. I'm going to write it in words because that'll help us with our algebraic expression. Multiply the input by 2. Then add 1. So again, the pattern rule is multiply the input number by 2 and add 1. To turn that into an algebraic expression, we can just say multiply the input number, which is going to be x, by 2, and then you add 1. And that is our algebraic expression. So we've done part 1 and we've done part 2. And I'm just going to highlight that we know our algebraic expression is 2x plus 1. And that sets us up well for our graph. So the next piece that we're going to be doing is we're going to be taking our table of values and putting them into ordered pairs to help set us up for our graph. Now, if you notice that I've added a third column here, please do the same thing on your page as well. I'm calling the third column ordered pair, and in brackets I have x, comma, y, because that is the order in which we're going to be writing the ordered pairs, and that is the order in which we'll be plotting the points on the graph. It's always the x value before the y value, because we're going to be looking at the x-axis, and then we're going to be looking at the y-axis when we plot. So the first ordered pair we have is going to be 1, 3, and we always put ordered pairs in brackets. Okay. The next ordered pair we have is going to be 2, which is the x value for the input, comma 5, which is going to be the y value for the output. And then the next one, the input is going to be 3. The corresponding output value is going to be 7, 3, 7. The next one would be 4, 9, because that's the input and then that's the output. And finally, the last values that we have here, we have 5 as our input, 11 as our output. So those will be the ordered pairs we'll be dealing with when we plot our graph. So at this point, I have jumped ahead, and you may want to pause the recording now in order to catch up with what I have written on my page. So what I've done is I've created an XY coordinate grid, and I've used a scale of 1 on both the x-axis and the y-axis. So remember, the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. So make sure you have those copied down on your page. Now it's up to you as to what scale you want to go up by. I chose 1 because it was the easiest and I had enough room. You could go up by 2s, you could go up by 3s. It's up to you. Just make sure your scale is even all the way on your x-axis, and make sure your scale is even all the way on your y-axis. Also, something to note is the spacing. Because you should be working on graph paper, make sure that you're making use of the boxes and the lines on the grid. Notice I've marked the lines with the numbers, so I'm well working within the boxes on the graph paper. You should be doing the same on your page too. Notice that I have even amounts of spaces all the way along. I'm not skipping any random spaces along the x-axis. I'm not skipping any random spaces along the y-axis. Where some people tend to make a mistake is that they have too much of a space between, say, 0 and 1 or 1 and 2, and then everything else is close together. So make sure you're paying attention to that detail. Now, I'm going to continue. If you still need more time, pause the recording and catch up. So remember that the x-axis, again, is the horizontal axis, and that's where we're going to look first when we're plotting our ordered pairs from our table. The x is known as the input in this case. So I'm just going to also jot down input here for your reference. The output is y. Now, my expectation is that you're always labeling the x and the y axis. You don't necessarily have to say input or output, but that's for your reference for this lesson. So we're going to be looking at the first ordered pair here. I'm going to do this part in red so that it's easy to see. I'm going to look at 1, 3. 1 stands for the x value or the input, and then 3 is the y value. So I know that's going to go right here. I'm also going to label it 1, 3. You do not have to label the ordered pair with the point. I'm just going to do that as a reference here. Same thing for the next one. I'm going to look at 2, 5 for our next ordered pair. I know that 2 stands for the x value, so I'm going to look at that first. You always look at the x before the y, and the y value is at 5, so I'm going to plot it right there. So that's going to be 2, 5. Okay. Now what I'm going to do for the next one here, 3, 7, is I'm going to look at 3, which is the x, and then I'm going to look at 7 where it meets up at the y value. And where they intersect, that's where you have 3, 7. Okay. Now, if you want to pause the recording now and do 4, 9 and 5, 11 on your own, please feel free to do so. So we know 5, 4, 9. I'm just going to continue is right here. And then I want 5, 11 is right here. Now, I could join these points in a straight line because there is a trend and the pattern continues. So what I'm going to do is I am going to join them like this, although know that the pattern can continue, right? So I'm going to take my straight edge and draw a line through the graph. The final piece you need to add at the top is a title. Now, an appropriate title for this graph, you could say number of tiles in a pattern, but that's pretty general. I would actually use what the algebraic expression is, or the rule. It's 2x plus 1, because that actually sets you up for later on when you're dealing with functions. And I'm going to underline that with a ruler. Now, as you can see on the graph, it's another grid representation of the pattern. We have the t-tables as one representation. We have the ordered pair as another representation. And finally, a third representation is the graph. We can see that each time the figure number, which I'm going to underline in yellow, increases by 1, okay, the output, which is the number of tiles, increases by 2. Which makes sense because the pattern rule is, or the algebraic expression is, multiply the figure number or the input by 2 and you add 1. And that is graphing patterns.